Good evening, everybody. This is Steve Wilson, and it's 8 o'clock Central Time. We'll start in a few minutes. We're waiting for a few more people to show up. We had a lot more sign up for today than we actually have on the call, so we'll give everybody a couple minutes. I believe we have a poll question. Yeah, in a minute I'll launch that as well. Thanks for coming tonight, and yeah, we'll get started in a couple minutes. While we're waiting, we have a poll question just to get an idea of whether you're here by yourself or you're with somebody else or you're in a group. Earlier in some of the webinars, we had some of the extension offices and other places that are supporting this project had viewing events set up at their offices, and so we were just trying to get an idea of how many people are on tonight. So I'll launch that. The poll is open. You should be able to see that now. And if you would, just vote, and we'll go from there. We'll leave that up for a couple minutes. We're still waiting. Hopefully a few more people will show. We had 63 register, so we're hoping a few more than are here. I'm going to close the poll here in a few seconds, and we'll get started. For those of you that were on time, it's certainly not, you can't wait forever, I guess, so I appreciate all of you showing up, and I'm going to close the poll. And it looks like most of you are by yourself, which is fine. Here's what, well, we're going to get moving. I'm not smart enough to figure out how to share that with everybody, so, oh, there we go. Let me try it. Looks like those are our results, and so let's get started. All right. All right, hopefully everybody can see my screen now, and we'll get moving. If you want to use the box on the right, the GoToWebinar box, to ask questions, feel free. If you have problems, you can't hear me, or there's some other issue, please let us know. I'm here tonight with Jennifer Wilson, who's from the Water Resources Center. I'm Steve Wilson at the Illinois State Water Survey, and together with Cassia Smith, who's not here tonight, we put together the private well class. It's sponsored by the Rural Community Assistance Partnership and US EPA. This is actually from a US EPA grant to RCAP, and they funded us as a grantee, so to speak, to develop this. The Water Survey has a long history in Illinois of working with well owners, and that's where all this came about. So we're putting kind of our knowledge to use, hopefully, in a good way. So, why didn't that work? Okay. So tonight we're going to talk about the class, and then what we're going to cover tonight in the webinar, a few logistics like using the question box, and then we'll go through the material, sum things up, and give everyone a chance to ask questions. Now, this particular area of the class, moving into more of the sampling and testing and what to sample for and those sorts of issues, are not necessarily my expertise. We have other staff at the Water Survey, chemists and geochemists and lab folks who have been on the last, were on the last webinar number 3 when we did that in May. And we did not ask them to join us tonight. And so there may be questions I can't answer, and if that happens, we will we'll take your questions down and we'll get those out either on our website, or what's probably best is if you email us, and we'll go from there. So the private well class, hopefully you're all familiar, is a series of 10 lessons that are sent via email. These webinars are meant to provide additional information. This is the third of 3, and they're kind of a summary of each of the lessons, and they give you a chance to ask questions. So assuming that you didn't find out about this from somebody else and you've been to the privatewellclass.org website, we're good. If you thought this was the lesson, then go to Private Well Class and sign up, and you'll get the lessons are much more detailed, provide additional resources and some of those things. This is the website, and click on enroll here for free. Again, this lists all the partners. We're at the University of Illinois. We're partnering with RCAP, which is a National Technical Service, Technical Assistance Organization, and the US EPA, who funded the development of this class. Down at the bottom, you can see the email address, info@privatewell.org, or privatewellclass.org. You email that, and it goes to Jennifer or I, and we try to answer questions. We had someone from Maryland actually contact us today, contacting their driller, trying to get them some information for their well. Again, I want to just make it clear, early in the program we had an issue where word of the email or word of the webinars was being passed around, but not necessarily the class. And so folks were signing up for the webinar not realizing they were not the class. And I just want to make that point. The way the class works, if you haven't taken the class, you sign up, you get the first lesson, and then a week later you get the second lesson, and so on. You get one a week for 10 weeks. And it's interesting, we have a post-test, a pre-test, and also we asked for folks to give us an evaluation at the end. And for every person who says the lessons come too quickly, somebody else says they come too slowly. And for every person that says they're too long, someone else says they're too short. And so we hope that we've done a pretty good job trying to balance all of that. And so let us know what you think. And if you're taking the class now, or you took the class and didn't do the evaluation, it's really important to us to know how everyone felt about the class, and if they really learned anything, and if there's other things we could have done to make it better. It's not going to go away, hopefully, and so we want to take everyone's comments and try to actually incorporate what we can that will help the next person down the road, and maybe eventually even provide some new lessons for those of you that have already taken the class. When you register for the class, we only ask for 3 things: your email, first name, and state where you live. The idea here is just to have your email address so we can send you the lessons. The first name really is no bearing, but the state where you live helps us. The EPA is interested in making sure that this is a national program, and so when we can show them that we've had folks from all 50 states and some of the territories and even from around the world who've taken this, it helps show that what we're doing is actually getting out there. Okay, so here are the 10 lessons. Hopefully most of you have been through these already. Starting off really about groundwater and how it moves and gets into your well, and then the components of your well, and moving to all the other pieces of your water system. You know, your water system is no different than a community water system, except that it only serves one home, and you're the person who's responsible. So in theory, you're the water operator that those folks who live in the community take for granted. And so there's things you need to do, best practices, ways, well operation and maintenance. And as we move through these lessons, then we talk about other issues. Once we get through the nuts and bolts in the beginning, how you can find information, then about groundwater quality, sampling, and water treatment. And tonight, this is the third webinar, excuse me, which is really covering lessons 8 through 10. And some of that goes back to some of the earlier stuff, just because it's important, and that's where we're at. So we are recording this webinar. This is the third time we've given this, and honestly, we'll probably end up with just one version on our website. Right now, I believe the May 15th version is up. I'm not 100% sure of that, and I forgot to change this slide. It won't be repeated one more time in August. This is the one more time in August, and so if you have questions, again, use the question box on the GoToWebinar screen, and we'll write them all down, and at the end we'll put all the questions up and try to go through what I can, and the ones that we don't or can't, I'll find someone who can answer those, and we'll get those on our website. And again, the lessons provide more detail than I will be able to provide tonight. So starting off, the important points to remember, I already kind of mentioned this. Private wells aren't regulated. There is no law in the states, in any state really, that says you have to maintain your well in a certain way, or you have to test your well regularly to make sure that it's safe. You're in charge of your well, and the thing that's ironic is you could have what you think is the best tasting and safest water in the world. It's clear, pristine, whatever. Many contaminants you can't taste, see, or smell, and so you can't go by that. And sometimes well that may smell just horrible. For instance, if it's got sulfur, smells bad. It's not a lot of fun to take a shower in a well with a lot of sulfur in it, but it won't hurt you at all. So you can't go by, boy, I've drank this my whole life and it's always tasted great. You need to test your well regularly to make sure that it's safe. Going back to the first point, many states now require the driller to take samples, either just for nitrate and coliform, or sometimes more constituents, anytime a well is drilled, to make sure it's safe and been disinfected whenever it's new. And after that point, the driller's off the hook, so to speak, and it's the responsibility of the well owner. Now in New Jersey, and I believe that's the only state, it may have moved to a few others by now, there are rules that say when you sell your home, you have to have a water sample collected. So it's prudent in that respect too, to make sure that your water's safe and that you've tested it and you know what's going on with your well. It may change the value of your home, for instance. So, and in New Jersey, that law has been in place at least 10 years now, and they get about 13,000 samples a year that are done by the state lab with the sale and transfer of property. And so that's helped them build a really significant database of what the water quality issues are in their state. It's actually, as a groundwater researcher, which I am, having that data set is really a cool thing. It's expensive for the well owner, though, and so there's a trade-off there. Okay, so source water protection and water quality keys. First off, if you aren't sure, you've never tested your well, you can find out generally, usually, the water quality of the aquifer you're using. If you've followed the lessons and you have your well log and you know what kind of aquifer your well is finished in, whether that be bedrock or sand and gravel, a lot of times Natural water quality samples have been collected by a state geological survey, or in Illinois' case, a water survey, Department of Natural Resources, or possibly some other state or federal agency. That data is generally available. You just have to ask the right people. You need to call your county health department and ask them. And if you can find out some of the natural water quality concerns, and I'll show a couple examples here as we move through, it'll help you understand what you might need to test for. And so another important point is understanding how your well might be influenced. If your soil type is sandy or your well is in a low-lying area, then there's more risk of flooding, introducing something where there's ponding water around your well, or if you still have an old-style well that has a pit, those sorts of things increase your risk of contamination. You know, a large rainfall event will wash a lot of things into a pit. Nowadays, I believe, I don't know for sure, but in most states, if not every state, a pit is not an acceptable way to put a well in anymore. You have to use a pitless adapter, and your well has to be sealed at the surface. And so those old wells that have been grandfathered in a lot of times can be a real hazard. And then also ensuring your well is properly constructed, which gets back to both the pit issue, because that's not considered proper construction today, and also things like using a sand point, or if it's an old dug well that was hand dug and has uncemented brick. If you're using one of those types of wells, what we recommend, and it's expensive, is that you talk to a drilling contractor or even your county health department to start with and get their opinion, but likely what they're going to suggest is that you convert your well so that you don't have the pit, or if you have a dug well, you look at other options for a water supply so that you can construct a properly sealed well that's protected. And in some cases that's not possible. I know I grew up on a dug well. That was there was no aquifer really where our farm was, and so we had a hand dug well that my grandpa dug in 1932 or 33. And that's the well I grew up on. You know, those kind of situations are not necessarily good. It was built in the V of a ravine where water could run through, so we always had enough water, but it also collected runoff, and it was uncemented brick. You know, there was a lot of water quality issues that we had to deal with, sometimes cloudy water, or, you know, it was actually in a pasture. We actually, the well I grew up on was a poster child, if you will, for all the things you shouldn't do with your well. So, natural groundwater quality, like I said, the first thing you need to do is investigate. You can probably find a lot out about the natural groundwater quality if you just look. First online, I helped someone today. I said you need to contact your county health department. That's the first place to go, or your water resources agency. A lot of times they have samples of natural groundwater quality, so you can determine, oh, this is an area that's high in arsenic, or this is an area that's prone to have radium. And, you know, the drillers in an area have, a lot of times if they've been there a long time, like the driller I talked to today from Maryland, it's a family business. They've been in business for over 60 years. You know, they know where there's arsenic in the natural aquifers, and there's another place where there's radium. And if you're not in those areas, it's not a concern. And as I said here, the agency that regulates well construction is a good place to start. And the best way to find that online is just type in your state name, like Maryland Well Log. And a lot of times one of the first 2 or 3 hits will either be the State Geological Survey or whoever the agency is that regulates well construction. So in Illinois, that's the Illinois Department of Public Health and their county offices. So you want to contact the county health departments. They have a lot of good information and understand and collect a lot of samples in many cases. Or it could be like in Washington State, it's the Department of Ecology. So every state's a little different, and finding that out and knowing where to contact them to start with. Those folks, it's their job to help you, and they really want to help you, and you know their whole mission is public health protection, and so they'd be more than happy to do some of the legwork for you to help find out what's going on with your well. And you know, there's 2 kinds of contaminants. There's nuisance and health-based contaminants. Obviously, health-based contaminants are a health risk, and A nuisance contaminant might be like iron, or like I mentioned, sulfur, where it's a bad taste, or it smells, or it stains your porcelain or your clothes. Sometimes those aren't a health risk, but you still want to remove them because they just make it not as pleasant to have that sort of water supply. And so your health department can explain a lot of that to you, and or send you to someone else. Maybe like in Illinois, sometimes they come back to the state water survey. We also have a lab, and our chemists have worked a lot with treatment and can give people advice on what things they might want to try, or if they have a problem like an odor, like a carbon filter may take care of that, or in a given situation they may say, well, you probably should test for this because this is what it might be. So so be sure to include the constituents you know might be a problem if you have a sample collected, and also we're going to mention some other things that are just a good general set of parameters to test for when you first test your well. Okay, so this is, as an example, if you look online, this is Massachusetts Department of Environmental Protection, and you can enter your address here. They've developed this mapping tool that will tell you if you have a risk of arsenic or uranium. They've mapped it. Obviously, their state has done a lot of sampling to determine where this may exist, and this allows you to know whether your private well may be at risk in some of these cases. This is actually a picture or a slide that I put together. This is Tazewell County in Illinois. This is a rural subdivision, so each of those is a home. We're looking at maybe less than what looks like less than about 1,600 feet, so less than just a little over a quarter mile from the left side of the map to the right side. And this is an area that has very sporadic high arsenic. And you can see in the course of this quarter of a mile on the far left is a well that has 82 parts per billion, which the standard is 10 for a community water supply, and less than about 600 feet east, a well has 4.6, which is below that. And you can see the variability in these homes. We found out about this through that there might be this issue originally because there was a high arsenic hit found back in the 80s in this area, and most of the residents assumed it was a new landfill that went in. And so the county health department and the state EPA together had sampled a large number of wells, I believe over 400. And the values were all over the map. In one place it would be as much as 250, and in others it was undetectable. And so this was part of a study we did to look at the spatial variability of arsenic, and you can see most of these wells are very similar in depth, and they're in the same aquifer. It's a sand and gravel aquifer, and yet the values go from, for instance, the house it's next to the to be sampled, TBS, is 73.2, and just to the east of it is a well that's 12.7, and another one's 9.1. And so very variable. And we found since doing this work that the arsenic is naturally occurring in the sand and gravel aquifer, and what tends to release it are chemical conditions. And when there's still sulfate in the water, the arsenic stays bound. When the sulfate is gone, it's microbially mediated. The bacteria in the groundwater change from sulfate-reducing bacteria to another kind, and that allows the arsenic to be released. I mentioned these types of bacteria. As early as the 70s, no one believed that there were bacteria below the soil zone in the Earth's crust and in groundwater. Now, since that time, scientists have found everywhere they look, they find bacteria, even in very extreme environments. So there are bacteria that's ubiquitous. Every type of groundwater and almost every depth, you can find some type of bacteria. It's the E. coli and coliform bacteria that we test for, one, because they're easy to test for, and two, because they're indicative of a waste or source from the surface getting in your well. And so if we found iron bacteria or sulfate-reducing bacteria in a well, it usually isn't a problem as far as water quality or any of those issues. They're not a type of bacteria that can make you sick, basically. So surface sources, speaking of which, you should isolate your well as much as possible from any contaminant source. I mean, that goes without saying. If you've been through the class, you've seen some of the information we provided. The idea is anything can seep in the ground, and even if you have, let's say that you have 100 feet of clay and silt as the upper 100 feet of the soil zone above where your aquifer is, water can slowly, very slowly move through that. It'll take a long time, hundreds and hundreds of years in some cases, and so it's not likely to be a threat to your well at any time soon. But water continually moves through every clay and every silt, and eventually it's going to cause a problem if there's some kind of source. So if there's a spill, or a tank overflows, or anything else that's done that's not that's put on the ground, it can eventually cause a problem. And in sandy areas where the soil is very sandy, you have much higher and faster recharge rates. Those can certainly cause a problem much sooner. And that's why a sand point is not recommended. And in most states, they're not considered a legal water supply for a new construction, because you're getting water near the surface and you're in a sandy soil, typically. And so there's more surface infiltration. If there's anything on the surface near the well, it can get in your well that way. So knowing the flow direction, going back to one of the early lessons, will also help you. If you know that the flow direction is a certain direction in the groundwater, then you need to look up gradient at a higher water level elevation in the aquifer and see if there are any potential sources that might be moving towards you. If you're in a subdivision, you may have 6 homes in a row. Unless you're the most upgradient home, the other ones will all be upgrading of you. And if they have septic systems or a septic field, that can be an issue. And it's something just to be aware of. Again, it depends on your well depth and how protected you are. In some cases, there are multiple aquifers. So the area I was mentioning in Tazewell County and showed the arsenic information, that's a deep aquifer that's as much as 200 feet below land surface. There's also a shallow aquifer that's only 60 feet below land surface, and there's a thick clay that separates the two. And so one doesn't necessarily affect the other at all. They have different flow directions in some cases, and they flow to different outfalls, different sources, different rivers. So, yeah, all of those things matter, especially surface soil type. If you have a sandy soil, then you're more likely to have things that infiltrate below the root zone and more likely to get into groundwater. So proper well construction and knowing your well type and where your well is getting its water. If it's a sand and gravel well, you likely have a screen. So for instance, in Tazewell County I mentioned earlier, those wells are a solid casing down to 200 feet, and then there's a 10-foot screen. So the water is actually entering the well at 200 feet, where if it's a hand-dug well, water's coming in from basically right at the surface to the bottom of the well throughout that whole stretch. And similarly for a bedrock well, most bedrock wells are drilled. There's a certain amount of unconsolidated material above the bedrock. So maybe you drill through 30 feet of clay or till, glacial till, and then you hit bedrock. You drill that well, say, down to 200 or 300 feet. Your casing, your well casing, goes, in most cases, 10 feet into the bedrock, and then it's seated. It's kind of sealed there. And the rest of the well is open. So you're getting water from 40 feet at the bottom of the casing all the way down to the bottom of the well. And so the geology can be much different in the bedrock. Could be 4 or 5 different units. There could be a shale in the middle of a sandstone or 2 sandstones, or limestone or dolomite, all those different things, and each one have its own chemistry, and so they can really influence your well water quality. I've used Minnesota Department of Health a lot in our lessons, mainly because they put out a lot of really good information, and I certainly recommend the materials. If you go on our website and look at the lessons, and then the supporting materials, you'll see a number of things from MDH. They put out, as I said, some really easy to understand and very detailed examples of what you need to do in setback zones. So this is the top half of a page for their selected well isolation distance requirements. So this is from the Minnesota rules, and so for instance, a vertical heat exchanger has to be at least 35 feet from a well. That's part of Minnesota's rules. It may not be yours. It's not Illinois. But the idea here is it shows you all the possible sources and things that you may not consider an issue that you need to be careful and make sure that you do not have your well close by some of these things. And here's the bottom half of that, and you can see obviously some are common sense. You know, an animal feedlot, I can't tell you how many wells that I've went out to sample in rural areas in Illinois that were in a feedlot or in a field. And if they're a shallow well, you know, the feedlot obviously has animal waste, and a field, if it's a typical row crop field, has had nitrate and pesticides applied, and it's just it doesn't make sense to use a well like that if it's shallow and it's not protected. You know, in some cases, a well may be out in the field and it's actually 200 or 300 feet deep and it's protected, and they've got a little grass stand around it and it's well sealed, and they may never have a problem. But it's just more of a risk if you don't have your well more isolated from any potential source. You know, even a well that's drilled properly and sealed properly eventually could get a crack in the casing, or can have some of the material along the well, maybe the seal in the grout area of the well or in the gravel pack wasn't completely filled, and so your well may settle and sink, and it'll cause a place along your well casing on the outside where things can go down by the well bore. So it's better to protect your well. So for testing, there's always a lot of questions. When, where, how often, how do I get it analyzed and by who, and what do I do with the results, all those things. Obviously, that's the biggest issue. It's interesting because one of the questions on the pretest for our class was what percentage of well owners have never tested their well. I took that from some research done in Pennsylvania, where it was 50%, and most people got that wrong and thought it was higher. And actually, the more people I talk to, it probably is higher. And in most cases, a lot of folks have never had their well tested. And it's like anything else. You need to maintain and understand what you have in order to be sure that you're protecting yourself and your family and your public health, or in your health. Okay, so where do you collect your sample? Most people and most health departments will tell you to collect it from your kitchen sink. One of the things that we've learned, we have a public service lab, and until about 6 or 7 years ago, we offered residents in Illinois a free water sample for inorganics and metals. And so we collected a lot of samples. Now, we didn't do bacterial testing. Our lab never has, and I don't know why. But a lot of inorganic chemistry that will tell you a lot about your well. And what we found is that if you have a filter, a softener, any kind of treatment, a lot of times that obviously changes the chemistry of your well, of your water. So what our lab has always done is whenever someone calls us and says, I'd like to get a water sample collected, we send them 2 sets of sample bottles, and if they have any kind of treatment. So even if they have just a softener, and that way they can collect one sample at their kitchen tap that's after the softener, and another at like an outside spigot that is before the softener. And what's interesting there is I did a small study looking at about 200 samples. This has probably been 10 years ago from our lab, where the raw water had arsenic over a certain level. And then I pulled out all of those that had softeners and looked at the water after the softener. And in some cases, a softener isn't meant to take out arsenic, but it does just because of the chemistry and some of the things it's removing co-precipitate with it. On average, a water softener took out 41% of the arsenic from the raw water for these places in Illinois. Now, some of those, it was more like 95%, and in others it was 0. The finished water after the softener was the same as before, but you just never know. It's worth knowing if there are any differences and trying to figure out why. And so the one thing using a lab, your state should have a list of certified labs, and you should also contact your county health department to find out if they do testing. Again, a county health department, I believe, this is the truth, cannot tell you can't use your well, but they can tell you what's wrong with it. And so they have, I know in Illinois, our county health departments can do some sampling, some more than others depending on the county, but they also have 2 state labs that they can send samples to for specific things, or if somebody gets sick or there's a known contaminant in the area. And so contact them. If they can't do your sample, they probably can, or if you don't want to use the health department, they can tell you a good private lab to use. And if you use a certified lab, they should give you really detailed instructions, exactly when to collect it, how to collect it, what you can and can't do, or in some cases, I know in some states where there are legal issues related to fracking and those sorts of things, now there are laws in place even that say you need to have the lab come out and sample your well with one of their staff, so it's done in a consistent and considered a legally binding way. And you'd have to talk to your state about those sorts of issues. We do not have that in Illinois. So what to test for? Again, it is different in every situation. You may have, in some parts of Illinois, there are iron bacteria problems that can creep up, and all that iron precipitates and clogs your system and stains all your pipes and everything else. Again, your county or state health department are your first, should be your first call. They should have information for your area and tell you if there are any contaminants that have been identified in your area. Also do very simple things like ask your neighbors or talk to your driller. If you've had the same driller who's helped you with your other issues and you're comfortable with your driller, they likely, if they don't know what to do, they can talk to someone who can help you too. So, a good driller that you can trust is quite an asset for a well owner. And, that I mentioned the person from Maryland today. I called the driller. They had drilled their well. Their master well drillers are certified by NGWA on top of being state certified. They take all the classes to maintain those additional certificates. It was a family-owned business. They even helped when I said this well owner was thinking about getting their sample collected. They wanted to talk if they should talk to the county health department. They even offered that the thing the well owner should do is make sure they know the tag number on their well before they call, because they're going to ask for it. So they're helpful. Those sorts of things all matter. And in this particular driller, knowing nothing else about them, after looking at all their information, I would certainly recommend. So sample for coliform and nitrate annually. They again, they indicate a pathway into your well. Coliform bacteria are an indication of human or animal waste, and so if there's or E. coli is, excuse me. But if you have those things, and the same with nitrate, it usually doesn't occur naturally in groundwater at a very high level. And so if you have those things, and because nitrate's so heavily used in a lot of areas, they're a good indication that there may be some breach in your well, or your well's not sealed properly, or some issue like that. And if you do find that, you should resample. I think I mentioned that. So here's another example from a state health department. This is the Rhode Island Department of Health. They have this map up on their webpage for well owners. Just if you're in the large area that's in the middle there that's colored, that is actually beryllium. There's a certain type of bedrock that has beryllium in it. Until I saw this originally, last year when I was doing some of the research for these lessons, I didn't realize beryllium was even a regulated contaminant, to be honest. We certainly don't have it in most places, but if you're in that area, they recommend you test for beryllium because it can be too high. It's kind of like fluoride. Most people don't realize that a lot of communities add fluoride to their water because of the health benefits for your teeth. but if there's too much, it's actually very bad for you. And there are certain places in the country where natural fluoride is too high, and so you actually have to put in treatment to remove fluoride. So now the little dots here are all there because of orchards. And, before there were a lot of health rules and before everybody understood the dangers of certain chemicals, arsenic was heavily used in orchards. And so if you're in one of these areas, there's been likely so much arsenic used as a pesticide that you probably need to have your well tested for arsenic if you're in this area in Rhode Island. But it's just an example of what the state may provide to tell you, here's the contaminants we may have that are naturally occurring or that may be a risk for you and things you need to be concerned about. So our sampling suggestions, and we've looked at a lot of what different states offer and suggest annually for coliform nitrate, and initially for the list that's here, you don't need to do copper if you don't have copper piping, and zinc and cadmium if you don't have any galvanized piping, but some folks do, and in those cases you'd also want to sample for that. Arsenic is fairly ubiquitous. It's the seventh most common element in the Earth's crust. Now, that's saying that there are certain areas where arsenic's prevalent and other areas where you never find it, but it's not a bad idea. And some of these other things are more of a indication of other problems you can have with your well. And again, your health department can help you with your results to these, but you need to know, I mentioned fluoride before, your pH and hardness are important to determining kind of your water chemistry, and this is a good set of things to check every 3 to 5 years. It costs a little more to do all those, but again, your well should last a long time if it's maintained and it's been installed properly. And so, there are wells that we come across still that are, nearly 100 years old and still in use. And that's a testament to the way that well was put in and the fact that they're probably in an area where it's fairly pristine groundwater, and so there haven't been any problems. This is from wellowner.org, which is the kind of the help site for well owners that the National Groundwater Association has tied to their webpage. These are some things that additional reasons why you might want to test your water and what things they might show. So if you have some kind of water treatment, for instance, the third from the bottom, and it wears out rapidly, then there's maybe a corrosion or a pH problem that could be due to pipes, or it could be due to some other issue. And so this list is on their webpage, and it's certainly, if you have a problem, again, my first recommendation is to go to your county health department and say, hey, there's a coal mine really close to my house. Is there anything I should be concerned with? And they will tell you, they'll get back to you or they'll have an answer for you, but there's certain things you should test for because whenever you disturb the ground like that, it can cause changes in water chemistry, or even dewatering for some things may change the flow direction of a natural occurring aquifer. I know there's issues sometimes with gravel pits where they expand and dewater, and that causes well problems of one type or another, usually a loss of water, but sometimes a water quality problem as well. As I mentioned earlier, every state accredits labs that are used for community water supplies. Matter of fact, it's the law that if I were the water operator at a community water supply, nearby town, that I have to use an accredited lab that's been certified by my state. And that's to ensure that the lab knows what it's doing, it's passed all the testing, that, many states actually give them samples that are spiked with a certain thing, and they have to prove that they know how to do the analysis. And so it's quality control, quality assurance. And so you should try to use a state-accredited lab if you can. And that may be your local health department if they have the facilities, or they may recommend one to you. But in most states, you can get on the web page for the community water systems that are regulated and some of the rules for water operators and those sorts of things. On those web pages, you can find a list of state-accredited labs and probably find one in your area to call. So there's also states in some cases have private well sampling programs. I know Iowa, for instance, has a program that their state legislature funds for a certain amount of money that goes out to the counties to lower the cost for water quality sampling for private wells, and also to help pay for sealing abandoned wells. And that was in the last webinar if you weren't in attendance. But abandoned wells are a huge problem. They can cause a direct conduit to an aquifer. People throw things down them, all those things. But there are states that have programs, and it's worth determining if your state does or maybe your county does. It may save you some money or provide you with additional resources on well maintenance and protection. And I mentioned this once before too, but a good lab will give you detailed sampling instructions and explain what you need to do. Most of the time you're storing a sample and preserving a sample. Now these days, because of liability, some things that you analyze for, you put a little bit of acid in a bottle and then you collect the sample, and that keeps that from coming out of solution and those sorts of things. A lot of times they don't do that now, because if you open the bottle and get the acid on you, it can cause a problem. And that's the legal situation that we live in today. But and if they're doing the sampling, I can guarantee you that they've got a few bottles that have a small amount of acid in them, and those are just for sampling for specific things. And they'll tell you how fast you need to get the sample in. In general, it's always best to get the sample in as soon as you collect it. And so if that means you're going to have to determine the best time to collect your sample so you know you can take it to the lab right after that, that's your best bet. The more a sample sits, if it's in the sunlight, if it gets warm, or if there are any other things in the water that can react, it can cause changes. And not that it will, but it's always best just to get the sample in and get it analyzed as fast as possible. As far as picking a lab, ask questions until you're satisfied. And that's really important, because don't pick a lab because they're the closest one to you or because they're the cheapest. If you have an uneasy feeling about who you've talked to, or they've sort of brushed over things and not really answered your questions, there are other labs, and you need to be sure it's your public health or your health and your family's health, and you want to know what's in your water. And so a good lab will provide everything for you, including good advice. And if you're not happy with them, you should consider finding somebody else. Here's an example of a free well testing program. This is New Mexico. It's more of a carrot to folks that have septic systems, which most rural well owners also have septic. But if you're one of their clients and you're involved in their septic tank program, then they will offer you sampling for certain constituents. And it's a good idea. They've got the lab to do it, and it also gets more people involved with the septic side of things, which what happens to your waste is just as important as you as part of your system. So for interpreting results, I'm going to show you a website that Penn State has, Pennsylvania Extension, in a minute. And you can look at all these websites and documents online you want, and they may give you a very good sense of what your results are. I would always still take them to your county health department or your state health department to get a qualified answer. That's their job. They understand what these things mean, or they can research them. They have a vested interest in making sure that you're safe. And so no matter what you think you've read and know online, even from a county or a state health department website, take it to a person, make sure that you understand everything they've got to say. And we always recommend, if you find something in your well, resample, especially bacteria. I don't know how many times someone's contaminated a sample by accident and not realized it. And so it doesn't take much. If your hands weren't clean, or there's a lot of different possibilities. So if you do have something in your well, the first thing to do is resample so that you can confirm what you found. So, and if you have bacteria, if you've done a coliform test and it came back positive, then you should also test for E. coli, which is the waste bacteria, and always boil your water until you can get it chlorinated, and add treatment if you need it. There are even wells that have permanent chlorinators on the top of them and that sort of thing. Other times, maybe the well had been opened, you had a pump work done, something like that, or you had to have something replaced, and that caused your E. coli problem or your some kind of contamination issue. And so chlorinating your well will take care of that. Everyone's going to ask, can I chlorinate my own well? You certainly can. And if you are going to do that, I would use the recommendations we provide in our lessons. And they're actually Minnesota Department of Health. They're very complete. They're very accurate. They talk about all the issues you might have. Really, if you, one of the other good options you have would be to use your well driller. They're professionals. They do this regularly. They can make sure that things are done properly. The worst thing to do is to go out and pour a whole bunch of Clorox in your well without reading any directions. And someone goes, oh, just go do that every 6 months. That's actually a bad thing in most cases because it can damage. It's too high of a concentration without blending and diluting, and it doesn't necessarily get chlorine everywhere it needs to be. There's a set of rules to follow and to make sure it's done properly, and that's why a lot of times it's better just to have a driller do it for you. Now this is the tool I mentioned on Penn State. It's the Penn State Institute of Energy and the Environment and Penn State Extension together. They've developed this drinking water interpretation tool. It's actually really cool. There's a couple things you need to know. All the results are reported in parts per million. See that red note at right above the empty boxes. And so that's milligrams per liter. And if you're gonna, if your sample results come back in micrograms per liter, you need to convert those. I know if you've taken the class and done the pretest, that's one of the questions, and that's why so many times people get their units mixed up and end up thinking there's some real problem that there isn't, or even more of a risk is where they see a small value, like if arsenic's reported as 1 ppm, and you think, oh, that's not very bad. Well, that's 1,000 ppb, and the standard is 10. And so you need to understand the units if you're going to use something like this. And again, this is meant to be more as a first cut for you to get a feel for whether you have an issue or not. You should still always take your samples and results to a qualified professional in your health department for them to interpret for you. And so if you type in some values here, what I did is I typed in 0.1 for arsenic and 0.1 for aluminum. And again, 0.1 is in parts per million, which is 100 ppb, and so it says no, value exceeds the standard. And again, the standard is 10, and that's for community water supplies. You can drink water with 100 ppb of arsenic your entire life, and it may never affect you. And a lot of people have. But what the EPA has shown, and a lot of other organizations around the world, is that when you have arsenic that high, you're more susceptible to getting certain types of cancer and not having other problems. It's not an acute problem. Arsenic has to be much higher than that to be an acute problem that you hear about sometimes in other countries. But over time, you drink that water that's high in arsenic, and it can lead to possible cancers, and that's why it's been regulated. And so arsenic, the standard is 0.2 milligrams per liter, and that's why it says yes, it meets the results. And they've even provided for Pennsylvania well owners. You can click over on the right for more information. These help sheets, or sometimes they're a book, an actual multi-page brochure, if you will, that provide some more information for you. And what I can tell you about most of the state document, like Pennsylvania's document, sure, it's geared towards the well owners in Pennsylvania and maybe more geared towards the geology they have there. But 90% of the material is relevant to a lot of folks in other states. It's just like a well driller or a water operator's exam. Every state may have a different exam for their operators, but only 10% of that material is really state specific. The rest of it is about treatment and issues that would be similar for anyone. And that's why our class works, because most of the material is actually very relevant no matter where you live. So, and if you need this URL, you can email us. I believe we also have it on our website under the resources. And it's, or you can just Google drinking water interpretation tool, and it'll be one of the top 2 or 3 links. So it's pretty handy as a first cut. So water treatment. Water treatment could be 5 lessons in a 5-hour webinar all by itself or more. And so we cover more things in Lesson 10. I recommend, again, I'm not a treatment expert. I'm more on the source side. And so I certainly recommend you look at Lesson 10 of our class and use that as your guide. I had help, obviously, doing Lesson 10. And so the best advice I can give you is talk to the right professional. And I've got that highlighted because home treatment and water treatment is a huge business. And it's a lot of times frustrating when you go to a home and they've got some really expensive treatment system that uses materials or filters or some kind of device that has to be changed or media that has to be changed out. And it turns out they have some common problem where they really got sold a very expensive treatment system they didn't need. And so it matters. You should look up the individual company that you're considering buying treatment from, make sure that they're reputable. And the Penn State Extension has developed this really great paper. It's called Home Water Treatment Perspective. And it really talks about all these issues, the do's and the don'ts, where you can get unbiased information. If they say, oh yeah, this has been tested, ask them if it's certified. I'll go through that in a second. I know there's a lot of ways to be safe and sure. It just requires you to do a little homework. And a little of your time can save you a lot of money down the road if you bought the right equipment versus something you maybe didn't need. So this Penn State paper, I want to talk a little more about it. The first thing to do is consider alternatives. If you have a really expensive water quality problem that's going to require treatment that's really expensive, maybe you can rehab your well, or maybe there's another source, which would mean drilling a new well. And even though that's an expensive option, in the long run, it may be cost effective. So in some cases, it's a matter of you know what the contaminant is. It's because you have a surface problem, and you can eliminate the contaminant yourself. You can stop doing some practice near the well that's causing this contaminant to get in your well. And so ask tons of questions. If you go to a well treatment or water treatment business, what do they know about the contaminant, about the company and its products? Always ask about maintenance, because sometimes you may not realize that you bought this, it's a $500 or $1,000 piece of equipment, but it requires you to replace a $200 part every 2 months. And, even though the initial cost was expensive, that other cost really can add up. And that's an extreme example. But if you have something that needs to be replaced very often, it's a continual charge, and you're going to continually pay it. So there's standards that have been set up. And ANSI and NSF standards are testing labs, and NSF is the National Sanitation Foundation, that test each of these treatment devices under certain conditions. So they provide a sample that has a certain level of arsenic in it, for instance, and then they run it through this treatment, and they run it until it doesn't work anymore, and then they put out information that says, this device is NSF certified to remove arsenic down to this level, and here's what we found from operating conditions and that sort of thing. Almost every device online has that, and if it doesn't have an NSF or ANSI, or there's one other lab, UL, Underwriters Laboratory, I believe. If it doesn't have one of their stamps on it, then I'd be skeptical, and I would try to find out more information about it. And again, go back to your health department or some other unbiased third-party professional that you can talk to. So once you get the information, it's like buying a car. My philosophy is you never buy a car the same day you go and look at them. And if someone's trying really hard to sell you that car and they say, if you don't buy it today, you're not going to get the same deal, then they've lost my business, because that's pressuring me to do something that I'm not comfortable with, and I haven't researched enough to be sure that I'm not getting, talked into something I shouldn't be. So always take that information back to the lab or health department and verify all the information is true. Research the company through Better Business Bureau if you can, and get a third-party opinion. And again, it's just to protect yourself and to make sure that you're doing what you need to do in order to have safe water and only getting treatment that you actually need. I mentioned unbiased information. NSF is the National Sanitation Foundation, Underwriters Laboratory, and there's a third association. It's called the Water Quality Association. Now, they're made up of vendors, and but they also do testing of the vendors' products. And so, being a trade organization, I just want to mention that, because they're the groups that pay for them to even be in business as an association are the folks that make these products. That said, they do very similar testing and sometimes even more rigorous testing on certain types of products. And so it's good to check all these out. And the, quote, regular standards that most people follow are the ANSI NSF standards. And so you can have Underwriters Laboratory meet an ANSI standard. It doesn't have to be NSF. It's just that they also do testing and help develop standards. It's kind of, there's a little bit of complication there, I guess, if you will. But it needs to have one of those symbols is the bottom line. And you can look on their web pages to see what they've tested and how well they've done, if they meet certain things. And when you go to most reputable home treatment device vendors or companies' websites, you can tell. You may ask for, let's say, arsenic treatment for your kitchen tap, so it does 2 gallons a minute or 1 gallon a minute, something like that. When you start looking at the prices, the ones that say, ANSI standard, that do almost the exact same thing as one that doesn't meet an ANSI standard, the cost is going to be double. And that's the bottom line. It's been through all that testing, and you pay for it, but you're getting a quality product. This is, I can't remember whose page this is from. I believe this is just from NSF's webpage, but they describe the standards and what they do. So softeners are NSF ANSI standard 44. RO, which is used a lot of times at a kitchen tap for arsenic, for instance, is NSF ANSI standard 58. And so there's all kinds of different things for different types of products. And each one of these have their own pluses and minuses. Again, talk to a professional. I myself have to talk to our chemists about some of these things. There's a lot of information, and it would be hard to learn it all. And so you need to find someone you trust and can give you straight answers on things for this sort of equipment. As I've said a number of times, your local health department is really your first line of defense. If they don't have the staff that can provide advice on some of the treatment issues, because not every health department has the funds, or their county may not provide as much. Just like in Illinois, there are some counties that have a smaller staff than others, and some have a complete lab and do their own testing. And it's because they're a wealthy county, they can afford to, and so that's one of the things they put some of their resources toward. But either way, a county that doesn't have its own lab or have a treatment professional on staff can find you the answers, because they're trained sanitarians, they all those things. So go to them first. Again, your lab should be able to give you suggestions on treatment. Now, if your lab recommends one vendor, then you still need to go through the same boat. The lab may get a kickback from the vendor for everyone they recommend. There's a lot of that kind of business practice. I'm not saying that your lab is less than reputable in any way, but you should always just be sure and safe unless you've used them before and you know them well and they've done right by you. So I'm loyal personally. If even having my car worked on, if someone's fair to me and has treated me right, that's the only place I go until they lose my business. So I think that's a good way to approach these sorts of things. And again, you're on your own. You need to be informed. And the more you know about your well and treatment and possible problems you can have and how the treatment may affect your pocketbook as well as the maintenance required and some of those things, it's your decision in the end. It's better to make an informed one. Okay, some common things that we probably can discuss today: POU versus POE, and that means point of use versus point of entry. And point of use means where you're actually using the water. So that would be, for instance, an RO unit that's at your kitchen tap. It doesn't treat the entire house. It doesn't do your shower or your bathtub because you're not necessarily drinking that water. And so, it saves you money as far as maintenance goes because the filter doesn't wear out as quickly, where a point of entry means where it enters the house or your distribution system in your house, and then all the water's treated. There may be something, I can't give you a good example. I can think of, corrosive, something that's corrosive, for instance. You may want to do that. Treat the water in such a way that it, makes it more balanced. But then you're treating all the water coming in your house, and a normal family may, just for basic use, may use 500 gallons a day, whereas for a point of use device at your kitchen tap, you may use less than 10 gallons a day. And so it makes a difference on what your costs are going to be. So you need to consider that if someone's trying to sell you a point of entry. Do you really need it, I guess, is the bottom line there. So be sure your treatment's your only option. Talk to your, if you're considering treatment or you need treatment, always talk to your well driller as well. Is there another option here I'm not thinking of? Is there something we can do with the well? Or, it depends on what the constituent is. I know in Wisconsin, for instance, there's a certain type of bedrock, and I don't know what it is, that's very, very high in arsenic, as much as 1,300 to 2,000 ppb. And they've actually passed a law that says because there's good potable water both above and below this one zone, and so if you're going to put a well that goes through that zone, you have to plug it off or use a packer such that none of the water coming in your bedrock well comes from that unit. And it's actually a good law. It's kind of frustrating, I'm sure, for the drillers. It makes things more expensive for the well owner if you go down past that, but it's necessary to protect public health. So, and the other good take-home message is about maintenance. I actually had one health department who was involved with this project early on from another state, excuse me, who basically wanted us to not recommend treatment and only as a last resort, because he's seen so many cases where someone puts in treatment and then they don't maintain it. And once that filter gets clogged, water goes around it, and all of a sudden it's not doing its job. And so you need to know what your maintenance requirements are, and understand that if you don't maintain it and you don't change the media, the filter, or whatever on a regular basis like it's meant to be and designed to be, you're back to square one. You might as well not even have it there. Okay, we're going to take a 5-minute break. I need to, I'm going to pop up here. It's 9:09. I'm not sure if we have any questions, and I have to check from the question box here. And if you have a question, make sure you ask. It looks like there is at least one question. So we'll take a break for just a few minutes here and give folks a chance to ask questions if they're going to, and then we'll come back and I'll try to answer those. And that'll be it for tonight. So hang on. We'll be back, let's say, at 9:13 Central Time, and we will answer questions then. All right. It's only 9:11, but we have one question. I'm having a little technical issue getting to the question other than through the question bar here. So the question we have is, why not have an electric line near the well? I guess I'm not sure what that question means. Um, Hang on one second. I need to contact Jennifer real quick and make sure there's not more to that question that I can't see. So if you would, bear with just for a second. All right. Well, I apologize. That's my mistake. So why not have an electric line near the well? Um, I'm not sure. Again, if you could explain what you mean by that. I mean, most wells have an electric line because your pump is generally electric if it's a submersible pump, and yeah, if you could give us a little more information on what you're asking there. As far as the second question, when I say bound, okay, so arsenic exists in the Earth's crust. It's the seventh most common element, and it's usually bound to an iron pyrite mineral, and so it's called arsenopyrite when it has arsenic in it. And that arsenic is bound molecularly to that material, and certain types of chemistry, like when the water is reducing, causes that to break off, if you will, and become free in solution or free in the water. And that's when it comes up in your well water and you see it. That takes a certain type of chemical reaction to occur whenever it's reducing conditions, which means there's not a lot of oxygen. And that's what groundwater, below the Earth's crust, whenever the water's been submerged for a long time, there's not much oxygen there, and so you have reducing chemistry. And I'm not a chemist either, but that's the process. And so the arsenic is released just in the minerals. It's from the minerals itself. Okay, so when you say it was released where it registered, if bound, it meant was held in water and so registered higher. When it's bound, it means it's bound on the mineral, and it's not free, and it doesn't come up in your well water. It's when it's released that it's just basically, quote, floating in the water. It's not bound to anything, any material in the ground, that it comes up with your well water. And that's a chemical reaction. Sometimes it's partially biologically mediated by bacteria, and so it can be very different in different places. Typically, if you have an area with higher arsenic, or there would be other wells in the area that also have higher arsenic, and that's one way you can find out. Your health department would know, and if any of the wells in your area do have arsenic problems, then that's when you'd want to go ahead and sample for it. Okay. Well, with that, I apologize for not being able to answer the first question. I'm not really sure what's being asked. Um, so, if you would, the person who asked that question, send us an email at info@privatewellclass.org, and I'll get back to you and try to ask some better questions to get at what you're really trying to find out there. And that's all we have for tonight. I appreciate everyone attending, and have a good evening, and I hope you enjoy the class. All right, take care.